Potentially the most challenging types of equations to solve are those with variables on both sides because they can be tricky sometimes. So remember on our Cornell sheet, we wrote the steps out. So the first thing you want to do is simplify both sides, which involves distributing and combining like terms. Once you have done that, then you want to make sure that you move the smaller variable by undoing it. And then you can finish solving. So these are the steps we want to follow. And I went through, if you need to go back to your Cornell sheet, how we got through this problem. But as we're working through these, we want to make sure we follow those. So always, if there are parentheses, get rid of those first. So we distribute the 2, which gives us 2c plus 2. Next thing you want to do is see if you can combine any like terms now. This only happens when they're on the same side. So these aren't, we wouldn't do combining like terms to put these two together because they're on opposite sides. So basically we would just want to make sure that the left side is simplified as much as possible and the right side is simplified as much as possible. There's nothing we can combine. And now that tells us we're ready to move the smaller variable. So 2c is of course the smaller variable. To move it to the other side, since it's a positive 2c, we will subtract 2c. So they'll drop out here. We get 2. 3c minus 2c equals 1c, or just c. And then we're left with minus 5. Okay. Now, if we would have moved the 3c, we would have been doing 2c minus 3c, and we would have gotten a negative c. And that's not wrong, but it will require an extra step of work if we have a negative c instead of a positive c. So that is why the suggestion is always to move the smaller variable so you can keep the positives, keep your variable positive, which we generally do a better job of. So once we have c here, we want to get c alone. So instead of subtracting 5, we will add 5. So we get 7 equals c. And don't forget, when you put it in set notation, you have to flip it over. Okay. Next. If you're ready and you think you can try one on your own, go ahead and try 2 on your own using those steps. So you can pause it here and try 2 on your own. All right, let's see how you did. We distribute the 2. We get 10 minus 4h equals 4h. And we might, if you're being hasty, you may make a mistake here, so be careful. We want to move the smaller variable. Which one is smaller, negative 4h or positive 4h? Of course, the negative 4h is smaller. So we're going to add 4h to both sides. This will drop out. We get 10 equals 8h. And again, you may be thinking, oh, I must have done something wrong. But sometimes we get fractions for answers, and you need to be confident. And know that that will happen sometimes. So if we want to get h alone, we want to divide both sides by h. Now there are 2 ways you can answer this. There's actually more than 2 ways. You can just reduce this. 10 and 8 are both divisible by 2, so we could write 5/4. Or if you wanted to, you could change it to a mixed number, which is 1 and 1/4. Or if you wanted to, you could write 1.25. So any one of those 3 answers would be acceptable. Because it is a terminating decimal, we can use a decimal. You can leave it as 5/4 if you want. Less work if you want to do that. So that's up to you. All right, next. Oh, we got a fraction in this one. So we're going to go ahead and get rid of the fraction the first step, because if I move the 7 over, that's really not going to help me in this problem. And if I try to move the x's while there's still a fraction here, that could prove to be challenging. So we're going to go ahead and get rid of the fractions right away by multiplying through by the denominator. So multiply by 3, multiply by 3, multiply by 3 over 1. So this one's easy. We get 3x. Negative 7 times 3 is negative 21. And here, the 3 on the top and the 3 on the bottom cancel, and we're left with 2x. No problem. Very simple. Next, we want to make sure we have the left side and the right side simplified, which we do. There's nothing else we can do. So we want to move then the small variable, which is going to be the 2x. So we subtract 2x from both sides. We get negative 21. And 3x minus 2x does give us 1x, but we can just write x. And therefore x such that x equals negative 21. 4 should look similar to a problem we've done previously. It still involves a fraction, and in this case you have no choice. You must get rid of the fraction first. So the denominator is 3, so we multiply this term over here by 3. And here is the tricky part. This is technically one term, I guess, right now. So we're going to multiply this entire fraction by 3, which is going to do something really nice for us. The 3 on the top and the 3 on the bottom will cancel completely, and you will always, always, always just be left with what is on the top. You are never, never, never going to multiply these by 3, because the 3 is going to be gone immediately. Always left with the numerator. So the numerator then is equal to 3 times 2n, which is 6n. Double check that both sides are simplified. Good. And now we're ready to move the smaller variable, which is the 4n. So we subtract 4n from both sides. We get negative 28 equals 2n. And then we need to get the n alone. So we divide both sides by 2. So we get negative 14. Again, if you want n such that n equals, if you want to go ahead and move the n to the left side in this step, I'm okay with that. And we'll get negative 14. When we get to inequalities, you won't be able to do that in one step. But here, it's okay with me. All right, now in 5 and 6, we're dealing with special solutions. And they will start out just like the others, although 6 is a wee bit bigger. But they will work exactly the same as the others, a little more challenging for this one. And then something weird is going to happen. So if you want to give those a shot, and see if you figure out where the weirdness happens, you can go ahead and pause here, try those on your own, and then come back and check them. So let's see what happens in 5. We are, of course, always getting rid of those parentheses first. So we get negative 6 minus 9x equals negative 9x minus 4. Can we simplify the left side or the right side? No. So the next thing we want to do is move the smaller variable, and here's where the tricky thing happens. Neither of these are smaller. So let's just pretend I'm going to move this one, and if I wanted to move this one, I'd do the opposite of subtracting 9x. I would add 9x. And because they were exactly the same size, they will drop out on both sides, so we'll be left with negative 6 equals negative 4. And here's where the notes that we took on Cornell will help you out. What is happening here is that all the variables are dropping out. And then we're getting a false statement. This is not true. Negative 6 is not equal to negative 4. So what this means is no matter what variable you put in here, you are always going to get a false statement that will not work. So we get no solution. Or you can write the empty set if you want. All right, so you don't have to write false, but it is due to the fact that this is a false statement that makes this have no solutions. All right, let's see what happens in 6. Got some work to do here. So we distribute the 2, we get 2a minus 16 plus 7, so leave the 7 alone. And then on the right side, distribute the 5, 5a plus 10 minus 3a minus 19. So remember, only distribute through the parentheses, not continuing on to these others. Now here's where most of the work is going to be done. We have to simplify both sides. So these are both like terms. We can put those together. Negative 16 plus 7 is negative 9. On the right side, we can combine the a's. 5a minus 3a is 2a. And then we can also combine the numbers. 10 minus 19 is negative 9. Now, some of you may already know what's going to happen here, but you need to continue and finish this problem. So we can't stop here. We sometimes make mistakes when we do that. So we want to make sure that we don't stop here. We do move the smaller variable, which is, they're both the same, so we're going to subtract the 2a. So we're left with negative 9 equals negative 9. So when you have a special solution, you need to go all the way to this step where everything drops out except the numbers. So the variables drop out, and you show me and you prove to me that the variables are going to drop out. And this is a true statement. So because this is true, it says no matter what a is, because a always drops out, this one's going to work every single time. So we have many solutions, but we're going to write all the real numbers. So every single number will work, every single real number. And you can either write it out, all the real numbers, or you can use the real number symbol if you want. So it's just a like line, line, and then do your R there. Okay, so we did write these on special solution. That's written on your Cornell sheet already, so you can use that to help you out. One final problem, a consecutive integer problem that's a little more challenging. So let's check this out. It says 3 times the largest of 3 consecutive even integers. So we're going to stop right there. I'm not even going to read anymore. I'm going to set up my 3 consecutive even integers. So x plus 2, and x plus 4. So whether it's odd or even, this is always your setup. Now it's talking about the large and the small. So let's call this one the small, and this one is, of course, the large. Now, it says 3 times the largest. So 3 times the largest is, now, it says 38 more than, twice the smallest. Now it says more than, so we have to flip that over. I'm going to write backwards. 38 more than twice the smallest integer, twice the small. Okay. Now, once I have that, I'm going to read it one more time. 3 times the largest, is, that's equals, 38 more than twice the smallest integer. So now we can plug in what these are. So the large is x plus 4. We need parentheses there so that we will remember to distribute through. So make sure you put parentheses around there. Here, however, the small is just a single term, x, so you don't need parentheses. You need a 2x. Okay, and then we've got a multiple step equation. So let's go ahead and work this out. Distribute, we get 3x plus 12 equals 2x plus 38. We cannot simplify the left side or the right side, so we're going to go ahead and move the small variable, which is the 2x. X plus 12 equals 38. All right, now we'll move the 12, so we'll subtract 12. I'm going to write kind of small if I can, and 38 minus 12 gives us 26. Now we're not going to put these in set notation. Oops. We won't put these in set notation because this is a word problem, so we need a sentence. So let's check these. X is 26. X plus 2 would be 28. And x plus 4 would be 30. Okay? 3 consecutive even. Yep. They did come out to be 3 consecutive even. And we can double check this. 3 times the largest, which would be 90, is 38 more than twice the smallest. So 26 times 2 would be 52. And when we add 52 plus 38, we do, in fact, get 90. Good. So the integers are 26, 28, and 30. Again, if any of this challenged you, you need to go back and watch it again. Definitely do that. Okay, you always have that option here.